Morning everyone, welcome back to my channel. In this video, we are going to discuss and understand another important concept in Kubernetes, which is called service. If you are keen on Kubernetes, then of course you are already known pods, deployments, and containers. However, many people still get confused when it comes to how communication really happens and how applications are accessed. That is where today topic becomes extremely important. So basically, today we will clearly understand what service is and why we need this service, how it works internally, and eventually what different types of services are available in Kubernetes. So before going to discuss with the service, let's start with some real-time scenarios where this service will be useful in Kubernetes. In Kubernetes, pods are temporary. They can crash, they can be recreated, and every recreation changes the IP. So if communication depends directly on pod IPs, application will keep breaking. So that is where Kubernetes introduces service as a stable layer in front of pods. Service gives a permanent access point and handles routing automatically to the pods. So that is where service become mandatory in Kubernetes. So let's see a couple of scenarios where the service will resolve the problems. First, we'll see the problem statements. Imagine you deploy a front-end application and a back-end application. The front-end needs to call the back-end continuously. Now, without service, front-end has to use back-end pod IPs directly. So today, back-end pod is example 10.0.0.1 front-end works. Tomorrow that pod crashes, a new pod is created with the 10.0.0.2. Frontend is still calling 10.0.0.1 request fails. So despite of backend running perfectly, frontend breaks only because the IP got changed. You don't want to developers to keep updating IPs after every restart. So this is the one of the biggest communication problem in Kubernetes. So the solution for here is you create a backend service. Kubernetes gives it a stable virtual IP. Frontend now talks only to the service IP, not to the pod IP. So in this case, pods may change, IPs may change, but service IP remains the same. So this is where service always knows which backend parts are active and automatically forwards the traffic. So front end continuously working without any change. That is where service removes the dependency on pod lifecycle. Okay, so this is the first scenario. And let's see the second scenario. In this second scenario, we will be focusing more on accessing on applications. So the problem statement is now imagine you deployed an application and you want users to open it in the browser. Without service, you would have to expose pod IPs to access that application. But pods are not permanent. This you already know. Today you tell users one IP, tomorrow pod restart, that IP is gone. Application becomes unreachable when the user try to access from the browser. So users face the downtime even though the application is healthy. This becomes a major reliability issue in Kubernetes while accessing the applications. So the solution here is you expose your pod IP using service. User access the service endpoint. Service route the traffic to available pods. If a pod is deleted, a new pod comes. Service automatically update the routing. So users keep accessing the same endpoint without caring about what is happening behind. That is where service become the permanent entry layer for application accessing. Okay, so this is the second scenario or second problem statement where the service will be helpful to resolve. Now let's understand how service connects to parts internally. Service works using the labels and selectors. Parts are created with the labels, service is created with the selectors. Okay, So service continuously scans the cluster and finds all the parts whose labels match. Those parts become endpoint of the service. Whenever traffic comes to the service IP, Kubernetes forwards that traffic to one of these parts. So service never depends on one part. It always works with a dynamic group of parts. This is where Kubernetes achieves a routing and distribution. Now let's focus on types of services available in Kubernetes. After understanding how service connect to parts, now we must see what types of services Kubernetes provides. Typically, Kubernetes offer there are different types of services, but majorly there are four types of services we are frequently using. The first service type is ClusterIP. So which is a default type for internal communication. And the second type is NodePort. This can be exposes application using Node IP and port. And the third one is load balancer, exposes applications using external load balancer. And the fourth one is headless service. For this, no service IP, directly part discovery. Okay, so depending on how you want to access your application, you choose the service type in your manifest file. And then we'll see what happens if a pod is deleted. If a pod goes down, deployment create a new pod. The new pod gets new IP. However, the service IP remains the same. So communication continues without the change. That means nothing will be interrupted. That is where Kubernetes gives the stability to, with help of this service, without interrupting anything, we can able to access the application. So the easy way to remember this service is parts are dynamic, services are stable. Parts changes. That means if it is restarted, if it is recreated, the IP is getting recreated. That means the IPs will not be stable, which is dynamic. So the service is stays stable only. So instead of parking your communication on parts, you park it on services. That is where Kubernetes networking becomes reliable. So the summary of this service is, so basically today we clearly understood why the service is required and then seen what problems existed without service and how service solved those problems, how service connect to the parts, and finally we have seen what type of services exist in Kubernetes. Service is not a optional in Kubernetes. It is the foundation of Kubernetes communication where with help of this service we can access our application based on the type. So in the next video we will start practically with the ClusterIP service first and then eventually we continue with NodePort, external load balancer and headless service. Along with that architecture we will be seeing and ML files and real demonstration also we can see in the live. So stay keen on Kubernetes, join technical huddles and we will continue step by step. So if this video helped you, could you please like, share and subscribe? So we will see series of Kubernetes videos and object by object. So if you can follow these videos, you will get overall knowledge on Kubernetes, how the Kubernetes works and how we can do practically. So once all the objects are covered, we are going to do the 3 projects in Kubernetes with the different tools and automation part. Okay. Thanks for watching.